In this video, we will learn about spherical mirrors. So, spherical mirror is a segment of hollow glass sphere having polished surface on one side. So, very important, if the outer surface of the mirror is polished and the inner surface act as a reflecting surface, it is called as a concave mirror. But if the inner surface of the mirror is polished and the outer surface acts as a reflecting surface, then it is called as convex mirror. Thus, it is clear that the reflecting surface of a concave mirror is curved inwards, but the reflecting surface of a convex mirror is bulged outwards. So let us demonstrate the action of a curved mirror by the activity. So here what we need to do is we need to study the action of a curved mirror. What we need is simply a shining spoon. So we need to take a large size shining spoon. So just try to view your face in its curved inner mirror. So what do you observe? So if your face is just near the spoon, you will see an erect and enlarged image. Means you will see the image inside the spoon which has to be enlarged. Now just move the spoon away from your face and go on observing the image of your face. When the distance becomes large, you will observe an inverted image of your face on the spoon. Means your face would be now inverted. So now you simply reverse the spoon and try to view your face in its curved outer face. Now you will observe an erect but diminished image. Means the size of the image is lower of your face on the spoon. So the image remains erect and diminished even when you move the spoon away from your face. So what conclusion do you draw from this? This is that the curved inner surface of a polished spoon acts as a concave mirror, but the curved outward surface actually behaves as a convex mirror. Thus, you have studied the action of both the types of curved mirror with the help of a simple spoon. Now let us learn some of the terms related to spherical mirrors. So look at a spherical mirror MPM shown in the figure. So this is our spherical mirrors. The spherical mirror is a part of a hollow sphere. So the spherical mirror is actually basically these are two spherical mirrors. These all are part of the hollow sphere. This is our complete hollow sphere. So the first term is pole. Pole is simply the geometric center of a spherical mirror is called at its pole. So this is our geometrical center. This is the geometrical center of this curved part. Okay. So this is the pole and this is also a pole. So this one is for concave and this one is for convex. Second, center of curvature. It is the center of the sphere of which the spherical mirror forms a part. So center of curvature is actually the center of that hollow sphere in the both cases, which is represented by C. Now radius of curvature. Radius of curvature is simply the radius of the sphere of which the spherical part, basically spherical mirror, forms a part. So the distance between the pole and the center of the surface and the center of curvature of a mirror equal to its radius of curvature. Thus R is equal to PC. So this is our it is actually equal to this PC. Next we have principal axis. It is simply an imaginary line passing through the pole and the center. The line is PCX, which is like this. So this is the line which is an imaginary line passing from the center of curvature and the pole. So PCX is basically our principal axis, or in this case this is our PCX, principal axis. Next is aperture. The length mm of the perimeter of the spherical mirror is called as its aperture. So aperture is simply this. This is the aperture. Then the principal focus. The point on the principal axis where a beam of light traveling parallel to principal axis after actually meets. In case of concave mirror, or appears to meet in case of convex mirror, is called the principal focus. So what happens in case of concave mirror? Some traveling, it will basically incident on this mirror and finally it will be reflected back at, which is called the principal focus in case of concave mirror. But in this case the light rays will strike like this and it will diverge somewhere like this, and where to be coming, this is the principal focus of the convex mirror and this is the principal focus of the concave mirror. So in figure, point F is the principal focus So it is clear from the figure that the principal focus of a concave mirror is a real point. That is, it lies in front of it. The principal focus of a convex mirror basically is a virtual point and it lies behind the mirror. So here, this is the concave mirror and these are the light rays striking the concave mirror and actually coming at the focus. So this is our principal focus. Whereas in this case, light rays are coming like this and they will basically moved away. So, and the point where they are appearing to be meet, these are the principal focus of this convex mirror. So focal length is simply the distance between the pole and the principal focus of a mirror as focal length and is expressed as PF equal to F. So this is our simply focal length, which is this. This is the focal length and this is the focal length of the convex mirror. So I hope it is clear to you. Thank you.